Today, I've got all the filament. Welcome back, ladies and gentlemen, to the oxygen that is included today. And the reason it is included today is because we are going to be building a real Algae Deoxydizer. Well, at least a model of it. Now, today's 3D model is brought to us by Joachim Lipka from Motion Brain over here. It was a freelancer. He does 3D design and 3D software development. You can go check that out. But he made a video over here, which is some speed art of him actually creating this 3D model that we'll be using today. So he gave me that file, and I've been able to import this into my CAD software, where if I need to, I can manipulate some things and we'll scale it down and get this thing just right. Because the other idea behind just making a nice 3D model here is to make it into a bubble machine, like a full-fledged, actually working bubble machine. I think that'd be absolutely awesome, because as you can see, bubbles and stuff come flying out of this thing, which would be, it's a good idea. All right, so he gave me two file formats here. I have STL and I also have FBX. And I found that the FBX actually works really, really good here inside of Fusion 360. So I've been able to import all of these into my little project folder here. And this is it all together. And all I've done here is actually scale it down from wherever he modeled it to something that I think is going to be a nice scale to print on most 3D printers. But you know, for my 3D printer, this will work pretty good in its time frame. It's not very big compared to how big I can print it. This here is a 200 millimeter by 200 millimeter cube, which is roughly how big this object is that I'm holding. This is about 200 by 200 by 200 deep. That'll give you some sort of idea of how big I expect this thing to be. But as we can see over here, that's the 3D model. And it does have several different parts here. And the nice thing about the FBX is that it gives me the mesh bodies. And once you have mesh bodies, you can go through and you can really start to manipulate things, convert it into a B-rep. And once I get into a B-rep, I can use my parametric modeling tools, which is the stuff that I'm comfortable with, because that's, you know, my background. I've worked in that for years. So I know when I make a hole that's defined by this dimension, that's how big that hole is going to be. So once I have it in this format, I then can recreate it into an STL after any modifications that I need to make as far as things, you know, needing to clear inside of them. And when you put a dowel inside of a hole, there's a good chance it's not going to fit, especially if it's a 3D printed object, because your tolerance that you have when you actually, you know, do additive manufacturing through a plastic extruded nozzle like that, I usually err on the side of plus or minus 0.2 millimeters. And a lot of these objects, as we can see over here, as we kind of break it into many different pieces, are going to be glued together, and some of them do fit inside of each other. So this right down here, the bottom bit that kind of holds that, I guess we'd call it the hose, the little flexible hose that goes up and down, that there is going to sit in this little ridge down here. So there's like a receiving pocket for that, and we'll glue it in there. So on top of that's going to fit this little like pipe clamp right here, you know, with the little adjuster on the side. And I can go ahead and take that and stick that on top of there, and then on top of that is going to be our funnel, which will go up there. And then we also have these buttons and stuff. Now if we take a look at the game again, what we can see is there's the colors that we have to work with right now. So the feet, and then the top bit right here, and also that first little ring where all the bolted connections are, all of those are kind of a goldish color. So what I have here is I have a couple of filaments. So this is bronze from 0. This here is what we're going to be printing most of that stuff with, because it's going to be kind of a lighter bronzish looking color. For the darker stuff, I went with gold from the same company, and as you can see, that's a little bit darker. So those will be the two colors that are going to make up the base there. Now for this very top piece right here, where we have that little like pipe clamp, that's going to be this gray color. Now I didn't go with silver because I didn't think silver really matched it. I felt like the gray was a good color. Not to mention it would work well with a lot of other prints that I want to make. And then I already had this color in mind for some different stuff, mainly because I think it shows details really well. So I wanted to have something to show off some really fine 3D printing. So I got this color right here, and that will be kind of for the rubber hose that's right in the middle there. This is a little bit lighter, but I do have black if this ends up printing a little bit too light. But I think that's going to be the right color right there. So all of these 3D filaments that I'm using here, I actually purchased with my own money. Nothing here is being sponsored, but you can find them down there in the description below. If this is, you know, filament, you like it, if you buy it through those links, that'll actually go to help support my channel. So thank you so much for that. All right, so looking back at this model here, let's go ahead and prepare this first piece for 3D printing. Now, Joachim here actually made two different base units, as we can tell. One of them is solid, and then the other one has a pocket in the back. And inside this pocket is where we can design a mechanism where we will actually make our little bubble machine. So the bubbles will, you know, kind of be held down here, and then we have a fan to kind of blow them through some sort of thing with holes in it. And then the bubbles will come up and out through the funnel, so it's actually hollow all the way through. So this is going to be the one that I'm going to focus on. All right, so you already know my very first step, and all I did is actually take this and scale it down. So if we find that scale button somewhere, yeah, there it is, right there. All I did is select all of these entities, and then I scaled it accordingly. And, you know, that's where I ended up to begin with. But the next thing I want to do is convert this to a B-rep. So I find it over here under the root node 1, we see bodies. And once I click on this, it highlights it. So I right-click on that, and I'm going to say mesh to B-rep. So at this point, that's what I did back here in order to make that into kind of a solid body. So I can turn off all of those mesh bodies here. Now I just have the solid stuff left behind. So you can see I got the one in the back and the one in the front. Now I'm not going to use the one in the front, so I'm going to get rid of that. But like I said, the thing that I want to focus on here. All right, so the next thing I want to look at here is how am I going to actually print this? Some side has to be facing down, and it doesn't look like I'm going to get away with no supports on this one. So if that's down here, what is going to end up supported? Well, this face inside of here, right there, that will all end up being, you know, under support material. Also, this hole here will end up with support material, not to mention this place right here, kind of where that fit is going to be. So that might end up being a problem because there might be a little bit of material that gets left over when I go to print that up. But for the most part, anywhere that's going to be exposed to support material is also going to be hidden. So I like that. And the topmost surface will be the face. Now, I think the 3D printer actually creates a pretty decent top face. So the lines will actually be different. It'll be the top face kind of, you know, pattern. And if we use ironing, it'll actually look quite a bit different. So I think I'll avoid ironing, and I'll just go with, you know, without ironing, and I'll probably end up printing it like this. Another option would be to print this face down, but then I end up with this back surface here being, you know, this all would need support. So another way I could print this is if I print it face down. Now, if I did that, this back surface here would need support the entire way because it's a big flat surface. You can't just print big flat surface over nothing. So one way I could do that is I can actually modify the back place here so that it's at a bit of an angle. And that way, when it goes to print, it will not be a flat surface. It'll actually have a self-supporting angle. So I could put that up to about 45 degrees or so. I can even go a little bit further than 45 degrees. My printer, as long as your printer can handle, you know, overhangs. They can print overhang up to 45 degrees pretty reliably. But I think the first way was the right way to do it. So what I'm actually going to do is modify this just a little bit down here so that it ends in an angle and I can avoid all of this support material. It's just going to save time. So if I go in here and I create a little sketch, things are going to hang out. All right, so I've sectioned this off a little bit so that I get a little bit better view of this. Hey, there we go. I clicked on one of those little faces and was able to just clean up that geometry so much. And then I'll go in here and I'll create a little sketch. This will be simple. I just use the L button to create a line. There we go. And then I hit D for dimension off that to that. And we'll see that this will be 45 degrees. And that's really all I need. Click on this space right there. And then I'm going to create an extrude. And I can just bring that all the way through. Now, I don't really want to have my section view anymore. So under analysis right here, I'm going to unselect the little light bulb there. Or I could just click on everything. There we go. Take care of that. And I must have accidentally dropped off of my... nope. Must have dropped out of my command. No! No! Go away! Since I'm not actually recording the browser history here, or so I say the event history, this is really just... I can manipulate it, and then I bring it back, and it doesn't really matter what I'm doing. It's just not recording it. So that just happened, and, you know, there's no history of it. So there we go. We just made that a little bit better there. Matter of fact, I think I can click on this and just hit delete and it'll clean it up. Yeah, beautiful. What if I click back here and hit delete? Boom! Oh, I love that. So much cleaner. I love it. There we go. That's what I wanted to see. Fusion 360, you know what's up. There we go. There we go. Boom! What happens if I delete one of these faces? Hit save. Delete. No! Oh, don't do that one. What about up here, huh? Yep. Boom! Super clean. Ah, yes? Nailed it. Oh, yeah. Man, I love it when stuff like this just works out. That doesn't really work when you start doing circles. There we go. I could just clean up all of this. Oh, beautiful. You have no idea how happy that makes me when I do that, and it just like works out perfectly. And at this point, I can drive any of these surfaces exactly where I want them to go and have them be nice and accurate. It's front face. Ooh, did that move? Nah, it didn't move. Inside of here, yep, there we go. A little bit of cleanup work. All right, so let me show you what I just did here. If I go over to the patch workbench right here, I can use this tool called merge, and that combines the selected faces into a single quilt surface. So by doing this, and then I select all these little faces right here from one side to the other. Ooh, what if I chain select? Will that just blow up? Ooh, actually it works pretty good. Saves me a click. So I've clicked on all those faces. I'm going to make that into one nice continuous surface by clicking OK. Perfect. Well, maybe not quite perfect. You see what happens there? Oh, bummer. It kind of is dipping in. Join surfaces to make a single surface body or solid body. No. Okay, so let me reselect these. Just out of curiosity, I'm going to click the faces next to it. This is why you click save, people. I've managed to dent our Algae Deoxydizer quite a bit. Well, I thought that was going to be a little bit better. Oh well. If I select all these faces and hit delete, it just goes back to a point. I could work backwards from that. All I'd have to do is hit the fillet button and bring that face in. And you can see what I can do right there. If I just make that 15, that will actually match pretty much what we had before. So there we go. We're just going to rinse and repeat this all the way around the model. Now the reason I'm doing this is because I feel like the geometry that I have right here, once we scale it up to a fairly large size, it'll end up that way in the print. And you'll be able to physically see all of these little, I don't know what we're going to call them, individual surfaces. And I don't really want to see that. So I'm just going to clean this up real quick. And it's pretty easy to do. You know, this took me 30 seconds to knock out. Right click. We have that little history that we can use. 15, hit enter. You know, just like that. Boom. Now I can increase the mesh as desired when I go to kick it out into my STL. The other thing that is probably real important here, even though I got carried away with like cleaning up all of this stuff that doesn't really matter, is these holes. I want to make sure that these fit, right? So what I can do is, now that I have this surface here, I'm going to go in there and I'm actually just going to create a circle. So all I did is click on that face right there and hit C, which is the circle command. And what I can do is I can create a circle to 3 points. So I'll just pick 3 different points here. And what that'll do is create the circle on the outside of the surfaces. The other way you can do that is actually do the flip side where it's just tangent to the faces. So one way to kind of maybe get a tolerance that works pretty good is to maybe do one to the points and one to the surface so that you get the outside and inside of what those, you know, where these are, where your tangents are. So we do that number and then we extracto that out. Oops. We want to go to the sketch, not to the face. So we want to find the sketch over here under the browser, which is the last one we just created. Click on that sketch and then hit extrude, which the shortcut is E. And I want to make sure that I'm selecting, come on. Oh, come on. Let me pick the other face, bruh. Ow, who would have thought? I click, hold for about 1 second. Profile, face. Oh, come on, let me just pick the sketch, bruh. I don't want to do, I just want this. Profile. No, face. No, no. I normally work in SolidWorks. Using Fusion 360 sometimes kind of gets you. This one here, this one's getting me because it's a very simple operation. All right, so you see how the dimension on that hole is kind of a weird number? It's 16.665 millimeters, so we're going to go ahead and make that 16.8. That way I know what it is. And I'm going to go ahead and just do that on all these different locations here. So we don't have to worry about doing it to each one. I was just trying to learn some stuff there. Come on. All right. Just don't cooperate. I'll make you work. There you go. Then if I use the equal, I can just click on here, go to the next one, go to the next one, go to the next one. Just kind of tie them all back so that they're, oh no, they're all the same. As long as you don't accidentally click the wrong thing. So now I should be able to pick the sketches, right? And then pull that out in all the locations. Yeah, that's much better. And then I can clean this thing up. Come on, don't do that to me. If I delete that. No? Nope. I guess it's satisfied with itself. Okay, so there we go. All right, so now I know that all of these holes here are 16.8 millimeters. So that's good. I can plan for that. I've done enough cleanup work here on that part to make that work. And now I'm going to come up here and I'm just going to clean this one up just a little bit so that it works well. So I'm going to make the outer diameter 93.8 millimeters. There we go. Same sort of idea. That first one is just going to become for construction. So now I should be able to take this sketch and grab this and extrude up from it. So long as I have all the surfaces I need. Be able to click that and grab all of it. Click the inside and grab all of it. Excellent. And then when I pull this up, that'll cut a nice hole. So that way when these parts go to fit together, they'll hopefully go together easily. Because I've made all the holes that were in this base just a little bit larger. So if it was line to line when it was modeled, it'll now be a little bit, we'll have a little bit of play when we go to put it together. So I'm going to do the exact same thing for the buttons here. You know, just offset it by 0.2 millimeters. And that should be all I need to do as far as to prepare this base model here for 3D printing and assembly. So now I've got the system worked out. I just use the 3 points. I just click on this, this, and that. And then what I'll do is I'll just use the offset command from that line and make it 0.1. And that makes that quite a bit faster. And that's kind of the thing about, you know, modeling and figuring out how you're going to approach these problems. It's that you don't necessarily get the most efficient way the first time, but if you keep thinking through the problem as you're doing it, you know, you'll definitely get a lot faster by the time you get to the end of it. And, you know, the next time you go to do this thing, you'll know the better steps to take to make your project go faster from the very beginning. That's the whole experience factor right there. So let's go ahead and turn that off. Pick that, get all your surfaces. Actually, I could just do this number, select all, bam, just like that. Matter of fact, if this is in the middle, I might be able to just mirror that. Let me go ahead and make a mid-plane just in case it isn't. Let's go ahead and modify this real quick. We'll just do some mirror stuff. So I'm going to mirror the feature, which is that extrude cut, and I'm going to mirror it across the center plane here. And what you can see is that now applied to the other side of the model, since this is a duplicate thing. I could have done that for this hole right here and, you know, made that operate quite a bit faster. It would not have worked up here because that obviously there's no point in mirroring that. So there's many, many different ways to get to the finish line, and hopefully I showed you quite a few of them to kind of get you thinking. And, you know, if you end up here inside of Fusion 360, kind of reworking some models that you have, then hopefully this will help you out. I'm going to turn that construction geometry off. So now the model is prepared for 3D printing. I'm really not going to worry about this inside of here. We're not going to see that. We're not going to have to worry about that. The only thing that I might end up, that I guess I could do, no. Sometimes if you take a hole, right? If you imagine this has a hole on it, if you print that, if you're printing vertically like that, it's really easy to print the hole. But if you put it on its side, you have all of this stuff in the middle here that's like out in free space, so it's much harder to print. But if you print it at 45 degrees, or just kind of at an angle of something like that, you can actually print it in its an ellipse shape. And as it prints up, it's self-supporting, so you don't actually have to have a you could print a hole that is self-supporting by printing it as an ellipse, being at 45 degrees. I can't think of a way to convert this into an ellipse, though, and have it work, so I might have a little bit of support structure right here. We'll see how it goes. No big deal. Oh, there's one last thing I can do, and that's with these little feet pockets down here on the bottom. Obviously, those are going to fit in. We got little feet that we're going to glue inside of here. We can see that in the PDF. It's one of the last steps right here, step 8. You're going to take those and you're going to put those up inside the body. One easy way to modify some geometry here is just to use the push-pull command. And what we'll do is we'll click on a face right there, and you can actually just move that face. Can you click on multiple faces, like opposing faces, and move them towards each other? You can. Whoa! Let's see here. Can I do that? Can I just click on all these faces and make it work? Oh, get out. Does that actually work? Oh, I don't know if it likes that one. Yeah. Alright, I might be getting a little overzealous with this tool. Let's dial it back a few. There we go. We'll offset those by 0.1. See, it didn't work. Alright. We'll just click all of these faces that are right next to each other and open it up by 0.1 millimeter. That's one way of doing it. So there we go. Wow, it hates this side. Everything seemed to work a lot better once I went and clicked on new offset instead of automatic. There we go. So that opened those up just a little bit. So now I'm actually done with all the different little things I need to do here. So we'll go ahead and click save. And at this point, I'm going to take this body and I'm going to save it as an STL. So you can see the amount of geometry that I have going on here. We can go ahead and actually increase the surface quality a little bit, since I really want those edges to be nice and clean, especially when we start to print it really large. And you can see just how many little triangles I'm going to throw at this. That'll give me some really nice surface finishes. All right, so you can actually play around with these sliders. The more to the left you go, the more triangles you have, the larger the file gets, the more difficult it is for things to process, but the higher quality mesh you have. And that high quality mesh really can translate into some really nice surfaces. If it's too low, you end up with things that look blocky or low poly, and that's not what I want. So I'm going to make that a 2, and then a 0.02. And yeah, there we go. Real nice. We'll let the supercomputer thing do its job. So there we go. Boom. That has been generated. Now I can go ahead and find that in my file. Paint 3D, huh? Let's see what this looks like. Okay. Whoops, I didn't want to do that. I've never used this tool. There we go. So that is the STL. Oh my gosh. Oh! You know, somebody really needs to talk to all of these people that do like 3D programs and just come up with the same way to move the model in every program. Because the struggle. Alright, so I've now loaded up this model here inside of Cura. You can see that's my printing bed in the back there. And now I got to figure out how, okay, we rotate this way. And it's already kind of in the arrangement that I want it to be. So we'll print from the bottom. And you can see some areas here that are in red. And those are the areas that are going to need support. We already kind of talked about that. With these up here, might need support. Maybe, maybe not. Maybe they're deep enough. Doesn't really matter. They're going to be hidden once we glue stuff in there. This obviously is an area that will need some support, although you probably could bridge it, but not a big deal there as well, because we offset those surfaces just a little bit to make everything fit a little bit better. So hopefully this works out. Now you can see how large this is. It's 150 by 112.5 by 150. So what I'm going to do is I'm actually going to go ahead and scale this down for the very first print. And if I like what I see, then well, I don't know. Right now, the holy cow, the amount of time it would take is 1 day and 483 grams of material. Hang on. Let's just do the layer view of this sucker. and see what kind of code we got going on here. I'm using a 0.4 millimeter with my own custom properties that I've set up. And you can see the infill here. Ooh, see, that's what it is. This infill is pretty stinking dense. So if I take that down to 10%, we'll see that drop down quite a bit, hopefully. 1 day, 4 hours. But I did drop 100 grams off, so that's good. If I go to the quality and I just say the layer height, instead of 0.15, I go to 0.2. That should make a big difference. Larger layer heights, faster speeds. It's one of the best things you can do to make things go faster is with layer heights. You can see how many hours we dropped off there. We're now down to 21 hours. We didn't really drop any material, obviously, because it's still the same sort of thing. As far as speed is concerned, the last thing that really makes a difference here is actually how fast you print. So I'm at 80 millimeters a second. That's probably a safe number for what I'm doing right now. I know that I can do 0.6 millimeter nozzle at 100 millimeters a second, easy, and the printer will actually keep up with that. However, let's just see here. If I flip this on over and we just hit discard on that stuff. So now, if I were to use my different hot end, which is 0.6 millimeters, which normally prints at 0.3 millimeter layer height, and at speeds of up to 100 millimeters a second, we'll see how long this will take. So instead of 60, we're going to do 100, and you can see that's now 17 hours. And it's still roughly about the same amount of material. You can see that it's still 494 grams right there. So I'm talking about half a roll, which means it better work. Although the support structure that's going on around this is kind of ridiculous. Hang on, no, go back to the center. We're going to lock that so it doesn't move. Actually, we're going to unlock that real quick, and I'm going to rotate this so that it's facing the camera, so you're not just looking at a blank back. That's just annoying. All right, so now the one thing that isn't accounted for here with the 0.4 millimeters is that the support was not being generated. So the time, we're going to see this time go up even more, and it was accounted for with the 0.6, so that it wasn't really an apples to apples comparison because the support geometry was not being generated. 1 day, 12 hours. Well, it's getting longer. Ooh, and I hate this support geometry over here. That just is nasty. What are you doing? Let's rotate this back. Sometimes you got to play around with like the support angle and which way it's working here, you know, to see where those helpers are. So right now, I mean, this, what is that even doing? It's not doing anything. Why are you making support there? What if I get rid of towers? Hey, that worked. That was just a little tower. That's all that was. So now we can see that the support material is running just like that. It's not going to look quite as good for the camera because I'm not quite rotated as far anymore, but yeah, that looks much better. Now it's doing what I was expecting it to do. All right, so you can see the infill material that I'm using here, and that's cubic. Now, you can do some stuff here to really save on infill. If I actually take this to 0, let's see how much of a difference that makes on time, just to see how much, you know, time we can save if we were to do 0 infill. Well, that brings it back down to 20 hours, which is quite a lot less. It also drops the total amount of material used by about 50%. So 50% of this model is going to be infill, even though the infill density is like really low. So if I use 20, and what I use is like different steps to gradually step it up as it's going up the model. Let's see how that works. Let's say 4, right? Oops, that's not what I wanted. Nope. Gradual infill steps. If I say that's 4, now let's see how it generates. Look at this. So the time still remains quite high at, you know, 1 day, but it's only using 275 grams as compared to nearly 500. And that's by doing gradual infill steps. So what this is really doing, let me just go ahead and kind of, we'll hide the shell, we'll hide the helpers. We're just going to show the infill as we step up here. So it's going to start off very large, and then it's going to try to grow up different ribs to support flat surface areas as it's coming up to them. So you see how it kind of grew up what was in the middle there, and then that's where the surface is going to be. So if I show the shell, you can see, you know, right where that shell ended up. And then as we go up further, we'll see that, that this is pretty much going to be 100% hollow right here. But then things get a little bit interesting once we get into the areas where this, that big circle comes into play. It's trying to support it more, which is probably more visible from this side. You can see how it's trying to come out from the wall. To me, I don't have a lot of faith that that would actually work like they're saying it will. I have a feeling that's going to create a big mess. And then as we go up higher and higher into the model here, we'll see that this will in turn, you'll start to see it get much more dense right here at the end. Just like that. Boom. So one thing that I'm seeing here is that it's quickly iterating through these different steps, the gradual infill step height. And I don't really want that to happen as quickly. So if I say 10 millimeters, so every 10 millimeters it can run through another, more densely packed infill. Let's see how that works. It's going to use up a little bit more material, but I want to see something that I think is actually going to work. And I'm not sure cubic is going to be the right solution for doing gradual infill steps. It does work really good for just normal models, but so it's starting off the bottom, and it looks like it's just going straight to the maximum infill right there. I don't have a lot of faith that cubic is really going to work as well as it says it will. We'll try cubic subdivision, see if that works any. 590 grams. Whoa! I don't like that. I do see what it's doing, which is really quite cool. So anywhere where it's much larger, it's actually trying to make those triangles bigger. What happens if we take this and we just run it to like 5%? Might be able to run a much smaller percentage, but that did look like it would print all right. It just looked like it would take forever to print and use up my whole roll. 335 grams. I can live with that, so long as it gets nice and dense before we get to a nice flat surface, right? And it doesn't. So let's change it back. Let's go with triangles. So the thing I don't like about the cubic setup is that it just has a straight line that just kind of ends in nowhere, and I only have 0.4 millimeter walls that it's printing. So I feel like that thing's just going to get all wobbly. If it does print at all, it'll just kind of end up drifting all over the place. I really want a pattern that has a complete section to it, right? So if it's a square, if we're just doing squares as infills, then I make a square, and if that square needs to get bigger, then it makes a bigger square. As long as it has, the lines end somewhere besides in Wi-Fi range, then I think I stand a good chance of actually having a successful print here. There we go. Up, up. That does work pretty good, but it's not transitioning between the areas all that great. All right, so this is me from the future. I've actually finished the print at this point, but there were a couple problems that I had with the previous G-code in there. And you can see here was one failed print, and then actually it failed twice. And the reason it failed is because there was like this little bits of weaving on the outside rim where it wasn't actually extruding any material. So the printer would go around and just, it would try to push some material out and then it would retract. Try to push some and retract. And it would do that over and over again without actually pushing the material out. So that there was like a little cross hatching that was happening on the outside here. Ultimately, I just went away from all the fancy infill and went back to lines as an infill pattern. So what lines does is that it actually alternates what direction it's going to go as it's going up the part. So it doesn't use that much material. The thing is, I've found that it doesn't really work too well with larger nozzle sizes, at least from what I've seen thus far, because you can get a pretty good opportunity where it'll start to build up little bumps and stuff that your printer will hit as it moves across the material. But you can see here it moves in this direction, and then the previous layer it actually moved in the opposite direction. The other thing I did is I set the infill density to 6%, and the reason I did that is because when I go to make this platform right down here at the bottom, I lined up that corner on a ridge where it will actually stick down. That way it isn't over in an empty space right there. So that was one of the little techniques I used to make the print be successful, and ultimately this was the G-code I ended up using. Now, the longest print I've ever done on a 3D printer was 5 days, and that was a large air duct sort of thing. However, that wasn't done on my printer. That was done on a like a T-Rex 2. And that was okay, but since the plate on that moves, the more weight you added to it, the harder that printer was working to try to actually keep up with the material on top of it. So, that's why I run a Delta with a fixed plate at the bottom. It doesn't move, so no matter how much material you throw at it, it doesn't change the dynamics of what's going on there. Keep the object still and just move the head. That's the way I believe all large 3D printers should run, but that's just me. Alright, so let's go ahead and add this guy up here, not to the cloud, but to the internal. There we go. Add it up, load it, and we'll get ready to print this thing. So here is the finished product, guys. I think it came out really good. Yeah, this top finish here looks real nice. The edges are nice and smooth. You can see on the inside here how we do get a little bit of that. You can see the different surfaces as it's moving around the corner. So that kind of shows you the difference. You see how that's got a little bit of a pattern to it. It's on the inside. We're not going to see it anyhow, but on the outside here it's much more smooth. The infill that was right up in here, I just couldn't get it off, so that stuff was kind of a little nasty, but again, luckily that part will be hidden. And the bottom ended up nice and smooth. You can see it was trying to lift a little bit right here, and I had a little extra bit right there, but for the most part that all worked out pretty good. And then on the bottom, where these feet are going to go in, that looks like it turned out really good. I really do like this material and the color of it. I mean, look at that. Beautiful. Do have a little bit of ghosting going on around this part here, but that's not too bad. The light's really making it worse than it is. If you look at it like that, hey, that isn't half bad. Of course, if you get it just right, there you go. So what goes inside of here is these little itty bitty like rivet heads. Now, this was a little bit of a challenge to print just because it's just so small. Look at that. Look at how little that is. So I might include that on the model, or if I were to do this again, but having the print be a little bit of a different, angle on how it's printing, right? So this is printing up. It actually makes it look a lot more like a rivet head as compared to if it was printing in the lines were going through it like that. Not sure if I care that much, but that fits right in there. Just got to kind of glue it in place. That'll look really good. So there's 1, 2, and then 3. Bam. Yeah, that'll look great. So there you have it, guys. That's all I have for you in this episode here. And you're going to have to let me know what you think about this. This is an entirely different sort of video. And while I do like being able to show you everything that I'm doing here is from start to finish, I have a feeling that many of you guys may only like certain parts of it. So what I really want to hear from you guys, since this is such a new video, is what parts of the video you like, what parts you don't like, what parts you might find useful, because I'm thinking that some of this material may end up on a second site as tutorials, right, or something like that, and then part of it will just be the build process. I think a little bit more instant gratification and a little less how I did everything might be what it works well for this channel, but I could still see value in the entire video. So let me know what you think about that in the description down there below. Also, links to the stuff I used in this, today. On one last final note, the 3D printer you're seeing inside of there is a custom design that I've come up with over the last 6 months or so. I've been trying to prove it out, develop it, and it's currently in the alpha stage. Once it gets to a beta stage where I feel like it's safe enough to end up in people's homes, you can find all that information down there in the description below as far as being able to get the files and start to build that unit yourself if that's something you want to partake in. It will get to the stage where people will actually be able to build this thing pretty much without having a lot of extra knowledge, because all that knowledge will be included in guides and whatnot. But you can find all that information in the description below. As per the time of this recording, a lot of that stuff doesn't exist quite yet. If you wish to support the project, there's going to be links down there as well, not to mention as supporting me as I try to go full-time here on YouTube. Thank you guys for watching. Have a great day. Stay awesome. Peace. Brothgar out.